a homework, right? Page 935, this is solving equations. The first three were just plug it in and see if it verifies the equation. Just says verify that the given x value is a solution. So I think they are all solutions. You just had to plug it in. 9, you had the answer for that one. 10 or 12, you did not. For 12, the answer should have been 5 pi over 4 plus n times 2 pi, or 7 pi over 4 plus n times 2 pi. The book says plus 2n pi, but it's the same thing, right? And 16 and 17, the 16 you didn't have, that should have been pi over 2. And the 20 should have been, if I can read it, pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. So, question. Which 21? Okay. So let's go through these. I'm going to record these. So 21, let's solve. 4 cosine squared x minus 1 equals 0. Okay, what's the first step in solving? This is number 21. What's the first step in solving a trigonometric equation? Isolate. So when I do that, that'll give me 4 cosine squared x equals 1, and divide by 4, cosine squared x equals 1/4. Okay, then what? Take the square root of both sides, right? Now, when I take the square root, I'm going to get cosine of x equals plus or minus 1/2, right? Plus or minus 1/2. So that means those are unit circle coordinates. So I need to, either take out your unit circle or just try to picture this. Remember, if you got one coordinate as 1/2, that means the other one is root 3 over 2, which is the bigger of the two. So cosine the x coordinate, if it's less than the y coordinate, that means it's up here. That's positive 1/2. That makes the y root 3 over 2. So it's got to be there. It's plus or minus, so it's got to be there, there, and there. Okay, now this one, the direction said in the interval 0 to 2 pi. So we would only list those 4 values, right? So x equals pi over 3, 2 pi over 3. Right, 4 pi over 3, 5 pi over 3. Do you see it? Which other ones can we do? I'm going to go back and do the evens, the ones that you didn't have, just to have them, just because I wanted to record something here. Oops, that's not right. Control I. So let's look at number 12. Sine x plus the square root of 2 equals negative sine x. Okay, how do we isolate the trig function when it's actually in more than one place? What do I need to do? Add the sine of x, right? So that's going to, if I add the sine of x, I'm going to get 2 times the sine of x here, right? And plus the square root of 2 equals 0. Then I subtract the square root of 2. Negative square root of 2. And then I divide by 2. Sine x equals negative square root of 2 over 2. And that's a unit circle coordinate. So I just got to think of where is the sine, the y coordinate root 2 over 2, negative root 2 over 2. Remember the root 2 over 2's happen. What's the other coordinate? If 1 is root 2 over 2, what's the other coordinate? Root 2 over 2. Remember, these are the ones that are right in the middle of each quadrant. right? And so if the sign is negative root 2 over 2, that means you are here or here, right in the middle of quadrant 3 or 4. So that would be 5 pi over 4 and 7 pi over 4. But again, we have to write it like this. X equals 5 pi over 4 plus n times 2 pi. Because every time I go around the circle, I'm back to the same place in either direction, right? And, or it could be 7 pi over 4 plus n times 2 pi. Okay, that's the 12. How about, what did we say was the next one? 16? Control I, 16. And this one is 5 plus 2 sine x minus 7. 5 plus 2 sine x minus 7 equals 0. So what would you have to do first? Combine like terms, right? I mean, on the same side, you got a 5 minus 7, so we combine. 2 sine x minus 2 equals 0. Isolate. 2 sine x equals 2, so sine x equals 1. Okay, where does the sine, the y-coordinate, equal 1 on the unit circle? Straight up, right there. And that is pi over 2. That one said just solve in the interval 0 to 2 pi, so that's it. That's the whole answer. And then the last one was 20. Was 4 cosine, no, 5 tan squared x minus 15. 5 tan squared x minus 15 equals 0. So isolate. 5 tan squared x equals 15. Divide by 5. Tan squared x equals 3. Take the square root of both sides. Tan x equals plus or minus the square root of 3. Now, is that a unit circle coordinate for tangent? It is. Whenever you get that for tangent, just, put a 1 on the other side of the fraction and then divide both top and bottom by 2. And then you'll recognize it a little better, okay? This is where the sine is either plus or minus root 3 over 2. And the cosine could be plus or minus 1/2. And looking at that, right, if the sine is root 3 over 2, that means it's further away, right? That distance is bigger than the x distance. That puts it there, or there, or there, or there. Which I think those are the same answers we got for 21. Right? So that'll be, let's see, this one is just in the interval, so we just have to say x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Done. Okay. Any other questions on any of that page out of the book? If not, then remember those 5 quiz questions. Right? Number 1 was sketch one period of the graph of negative 2 sine 1/2 x. So let's remember, we don't have everything going on in this problem. So let's remind ourselves what could go on in one of these problems. So we're doing sine y equals a times the sine of b times x minus h plus k. Okay, what is the number in front of the function determined? Amplitude. Remember, the amplitude is the absolute value of a. So in this case, the absolute value of negative 2 is 2. So it's the amplitude of 2. Okay, what does this b do? The coefficient of x inside of the trig function. What does that determine? Say it again. The period. Remember, the period is 2 pi divided by b, which in this case is 2 pi over 1/2, which is 4 pi. Okay, now, what would the h do to this? If you add or subtract inside the function, that would be horizontal, left or right. Right, minus means right, plus means left. Okay, what does the k do? Vertical, right? Plus means up, minus means down. Okay, so all we've got going on here, well, we got one other thing that's going on. What does the minus do to the function? Yeah, if a is less than 0, flip. And it is less than 0. So we're going to draw our graph. Remember, these graphs always look about the same. It's really how you label the axis which changes. Now, normally we would expect a sine function to start at 0, 0, and to go up and down and up again. But because it's flipped, it's actually going to go down and up and down again. And we know the period is 4 pi. So I can label that. Okay, starts at 0. The amplitude is 2, so it goes from -2 to +2. And there's nothing else to put on there. That was number 1. Okay, number 2. Write the equation of a cosine function that has not been flipped, so it could be positive, has an amplitude of 1, right? A equals 1. Has a period of pi, okay? So 2 pi over b equals pi, right? Therefore, b equals 2, right? 2 pi over 2 would give you pi. It has a horizontal shift of pi over 4 to the right. That's going to give us a minus pi over 4 inside, right? And it's a vertical shift of down 2, so that'll be minus 2. So y equals 1, which I don't have to show, cosine of 2 times x minus pi over 4 minus 2. Okay. So that would have all those characteristics. Okay, the last 3 are the same kind of problems, right? It asks us for the sine, or solve for theta, when the theta is actually the angle inside of a trig function. So how are we going to get at the theta? How do you solve for theta? You use the inverse, right? Got to use the inverse. But remember, when you do the sine inverse, which 2 quadrants will it give you the answer in? Only 1 and 4, right? Between negative pi over 2 and pi over 2, or between negative 90 and positive 90, right? So in all of these problems, where you're going to get the output from the calculator is not actually where they want it. So if I'm going to find what's theta, so that sine theta is 0.34 and theta is between 90 and 180, that's in quadrant 2. So we're going to have to do a little bit more work. So the first is we got to go, get my calculator up here, theta for 3, right? Theta equals sine inverse of 0.34, right? Theta equals, and let me clear. When you see that all these here, it tells you the range for theta is in degrees, then you should have the calculator in degrees, right? If they're giving you pi to pi over 2 or whatever, then it needs to be in radians. So if it's giving us these in degrees, make sure your mode is degrees. Degree. Okay, second clip. So we've got to do second sine inverse of 0.34. And I'm getting 19.1-ish, right? 19.1. Okay, but if I look on the circle, 19.1 would be in the first quadrant, be like right there. Right, so we would need to go to quadrant 2. That means we're going to go straight across to here. How do I find that angle? Yeah, you can have to do 180 minus 19.1. Right, which is what, 160.9? Okay, let's try the next one. 4. Theta equals cosine inverse of negative 0.75. So theta equals second cosine inverse negative 0.75. 138.6. Yeah, but looking at the circle, right? What quadrant is 138.6 in? It's in the second quadrant, right? It's somewhere over here. That's 138.6. But we want a theta which is between 180 and 270. That's in the third quadrant. So how do I do that? I go straight down, right? How do I find that angle? Say again? 360 minus 138.6. Right? If this is 138.6 around that way, we want to go 138.6 around that way. So that'll be 180 minus, 360 minus 138.6 equals 221.4. Okay, and 5. Tan inverse of 1.5. Which two quadrants is that going to give me an answer in? Quadrants 1 and 4, right? Tan inverse will always give you something between negative 90 and positive 90. But of course, we need this in the third quadrant, which is not good for us. So 1.5, 56.3. Okay, but looking on the circle, quadrant 56.3 is in the first quadrant, so maybe it's about right there. How do you find another angle that tangent has the same value? Add 180. It's straight across the circle, right? So if I got to go straight across, that means I'm adding 180. So plus 180 equals 236.3. Remember, you could always verify that by just, plus 180, and then I can take the tangent, tangent of second answer, and I get 1.5. So that's correct. All right, any other questions on any of the homework? Good to go? Okay, let me stop this.